Hello everyone, today is day 66 of solving a LeetCode problem every day, and today I'm solving validate binary search tree. So given the root of a binary tree, determine if it is a valid binary search tree. A valid BST is defined as follows. So the left subtree of a node contains only nodes with keys less than the node's key, and the right subtree only contains nodes with keys greater than the node's keys, and both the left and right subtrees must also be BSTs. So all that means is that you have a node. The node's left child is going to be less than that node, and the right child is going to be greater than that node. And this property applies throughout the whole entire tree. So what this question is asking us is we're going to be given a tree, and we just have to make sure that that tree has the following properties. Cool. So the way we can do this is recursively. So what we basically know is if we get the very leftist leaf node of this tree, it's always going to be greater than negative infinity, or it's always going to be greater than negative 2 to the power of 31. And we know that the very rightmost child is at most going to be 2 to the power of 31 minus 1. So what we can basically do is go through the tree, and we can check, starting out with the root node's value, we can make sure that it's less than the right bound and greater than the left bound, which is going to be negative infinity for the left bound and infinity for the right bound. So we see that the root node's value is within that range. So now what we're going to do is we're going to recursively call that method to both the left and right subtrees. So we go to the left subtree, and now we update the right bound. Since we know that the left child node of the root is going to be less than that root value, we know that once we go to this left child, any node in this left subtree can't have a value greater than this root value. So what we're going to do is call that same method, except with negative infinity as a left bound, and we're going to have the root's value as the right bound, and do the same thing with the right subtree, except we're going to have infinity as the right bound, and now the root's value is the left bound. And we're going to recursively call that method throughout the tree, and that's how we're going to solve this. So we're going to call the method isValid, and it's going to take a node, a left bound, and a right bound. And then the base case is that we reach a node that's null. So if not node, at this point, we can just return true, since we know that this node is going to adhere to the BST properties. Next, we want to see if this node is between the left bound and the right bound. So we're going to say if not, left is less than node.value, which is less than right, then at this point we return false, since this node breaks the binary search tree property. And then finally, we just want to recursively call this method on the children nodes. So we're going to say isValid, and we're going to pass in the left node with, let's see, since it's a left node, the left bound is just going to be left, and then the right bound becomes the root's value. Sorry, I'm at node.value, since we're going to be getting the node passed in from here. So this is going to be node, and then we're going to do the same thing with the right subtree. So and isValid node.right, and now the left bound becomes root node.value, and the right bound stays as right. And the reason we're using and is because we want to get true returned for both the left and right subtree. So if we used or, if the method failed on either subtree, if the method failed on one subtree but succeeded on the other, then it would return true in that case. But that's not what we're looking for. We're looking that both subtrees adhere to these properties. So now we can just call this method. So you just want to call this method with the left bound and right bound being values that are outside this range. In Python, I'm going to do this using negative and positive infinity, so we can return is valid, passing in the root alongside negative infinity and infinity. So if I run this, that shouldn't be capitalized. And this should be left bound and right bound. Same thing here. All right, cool. So the time complexity of the solution is gonna be O of n. And the reason why it's O of n is because we're processing each node in this tree once. Since, we start the root node, we compare it with left and right bounds, then we do the same thing again for the left and right subtrees, but we don't process any node more than once. As for space complexity, it's going to be constant within the method itself, but this is a recursive method, so it's going to take space up on the call stack, which is something that you might want to note. But yeah, that's the solution for the day.